to start with Chapter 3. Chapter 3 is surface area, volume, and capacity. Begins 3.1, surface area of prisms. So we'll take a look at this. To do surface area of 3D objects, you're going to have to know how to do area of 2D objects, because you're basically just going to add them up after. The two that are not too familiar would be the parallelogram and the trapezoid. These other ones, rectangle, square, triangle, and circle, should all be very familiar to you. These ones are not on my formula sheet, so I'll likely not really test you on them. So we'll probably just ignore questions that involve the parallelogram and the trapezoid. So those are already done for you in your book, so let's start with Builder Skills number 1. Area of a circle, pi r square. Use the pi button on your calculator, input the radius, just like this. On the calculators, you're looking for the power button, might look like that, might look like that. Some calculators have the x square shortcut, you can use that one. Make sure that you always use the radius. If they give you a diameter, just divide it by 2 to get the radius. Next question is a triangle, so a triangle would be base times height divided by 2. The big thing here is make sure you use the appropriate numbers. So the height is always perpendicular to the base. Okay, so you can see that there. So the base value is 9.3, the height's value is 5.7, then you'll divide by 2 after. Remember that with area you use square units. So let's calculate these. So for the first one, it's pi button power and then times 44 power 2. So and I'll go 6082, I'll round it, so 0.1. The unit is millimeter, so the area will be millimeter square or square millimeter. The other one, 9.3 times 5.7 divided by 2, I'll round it, 26.5, and this unit is square meter. Those other two are very similar. I'll skip parallelograms. Make sure you use the height that is perpendicular to the base. Okay, ignore the slant heights. And this will be similar to this question right there. These shapes says, what do you notice about the area calculations? Well, all the values are the same, so for these 3 triangles, the areas will all be the same. And for these 2 shapes, because it's the same formula, length times width or base times height, you'll get the same value. Example 2 is an example of an irregular shape. Irregular. So when we ever get weird shapes like this, all you want to do is sort of problem solve your way through it and make shapes that you're more familiar with, and then add up those areas separately when you do the calculations. And the book has a solution for that. So let's work on Build Your Skills number 3, 4. So problem solve would be to draw a line like this. Now you have 2 areas. Okay, let's call the first one area 1, and let's call the second one area 2. So in order for us to do these questions, we're going to have to figure out some dimensions. Area 2 is actually quite nice because they give you both 8 and 7, length times width. So let's figure out area 2. Area 2 would be 8 times 7, giving us 56. And area 1 is going to be a little bit more challenging. Area 1 is going to be harder because yes, we can use this 5, but what is the longer length there? So you'll have to realize that you're going to break it into two parts and then add it up. So that distance is 8. This distance here is 6.5. So you'll add those up. So for area 1, we'll use 5 for the width, and the length that will be 8 plus 6.5. So just add those first. It's 14.5. Times it by 5. Gets 72.5. Now we can add up those two areas, A1 plus A2, and we'll get the area of the irregular shape. So let's call that the total area as 128.5, and the unit is inch square, or square inch. Lovely. So moving on to the next one. We'll have to problem solve like that. Now we have a rectangle and a triangle. Let's do A1 like this. A1 will be super easy because it's just length times width. So 4.2 times 7.8. We're getting 32.76. Now this triangle, the base is known. It's 4.2. The height, we're going to have to figure out using some problem solving. So what we want is this height. So you can see that the total distance is 9.6. Take away this distance, 7.8, and you'll get this leftover piece. So 9.6 minus 7.8, that's 1.8. That's what we'll put for the height of the triangle. So base times height divided by 2, and we will end up with 4.2 times 1.8 divided by 2 is 3.78, and the unit would be square meter. Alright, this question says show 4 different ways, but let's just do it once. I usually break it down like that. Let's get some measurements in here. So how can we figure out this distance, the unknown distance? So we have 8.8 running that way, 8.8. Take off 4.6 and 1.8, and you'll get that missing distance there. So 8.8 minus 4.6 minus 1.8. Here is 2.4. We know this side's 6.2, and I think we have everything that we need. Alright, so let's do area 1, area 2, area 3. Area 1, length times width, 6.2 times 4.6. So area 1, using those two, 6.2 and 4.6. Area 2 is a small little rectangle there. Oh, we don't have, yeah, that's what we need. We need this little guy right there. So we can see that 6.2 runs the total length like that. We have a 3.6 here, so if you subtract those two, you'll get the leftover piece right here, 2.6. So let's times 2.6 and 2.4, and that will be area 2, length times width. And the last is the area 3, and these are both known to us, so 1.8 and 6.2 times those two together get 11.16. Let's add these all up, and area total .92 square meter. Alright, so let's move on. This page has some definitions about prisms, what a base is, what the lateral faces are. So make sure you give that a read. The big idea here is that, so let's take a look at the triangular prism. So here's your triangle. What happens is there will be another triangle down here. So in the 3D space, it's like these two shapes are running parallel to each other, and then what you have is a perpendicular drop to each vertex, and then what you get is a 3D shape. Okay, so there's like a front rectangle, here's a side rectangle, you get the triangle on top and the triangle on the bottom. Okay, and so like on this, here's the base, because the other triangle's face is over here, and in this sense these triangles are running parallel to each other like this, and then the lateral faces are perpendicular to the base. So important to know how the prism is built. I'm not going to worry too much about things like this where it's an odd shape like a hexagon or octagon. I'm mostly just interested in the squares, the rectangles, and the triangles. Also, these oblique shapes like they have here, we're not too worried about that. So we're mostly worried about the standard shapes that are right angled, nothing on the slant, or oblique is what they're calling it. So I'm really not interested in this page. So for example, here is a 5-sided figure, so this is a pentagon. So I guess this would be called a pentagonal prism. Not too worried about that. Mostly interested in the triangular prisms, the rectangular prisms. These ones, no big deal. The next thing is net. So a net is a two-dimensional map, if you will, of what a 3D object would become. If you think about a pizza box, like a Pizza 73 box, for example, you could unfold it all and make it flat, the piece of cardboard, and then you could fold it back into the box. So that's a net. We'll practice drawing nets. My recommendation is to start with the base. So here's the base. So draw a rectangle. Label the sides, so 15 and 5. And then imagine these sides like folding down. So it's like, here's the front, which is also going to be 15 and 5. Here's the back, which is also going to be 15 and 5. Then the sides would fold down like this. The sides are squares, 5 by 5. And then all you need is the top. So the top, which is parallel to the base, is going to have to be put on any one of these sides. Doesn't really matter. I think most people might just draw it like this. So this would eventually come up to the top when folded up. So here we go with the triangles prism. I would just imagine this folding down, this folding down, this folding to the side, this folding to the side. So I would probably start with the rectangle, which is not necessarily the base. Let me just color that in. I would start with this. Okay, so there's my rectangle. Fold a triangle down there, fold a triangle down there. And then this would be the rectangle like that, that would fold up. Important to note that this would have to match with this so that when it folds up, it lines up perfectly. So this would have to match with this as well. Now I've got marking all over that, so let's see what we got here. So it's an equilateral triangle. So all these rectangles will be the same. So 3, 3, 3, 3, 3, 3. So this is 3, this is 3, this is 3, this is 3, and this is your 14. So not too bad. Definitely don't care about something like that. Okay, so surface area of a box. This is a skill you definitely need to know. And here it is. I've already worked this out, so I don't want to redo it. Oh, and this is actually the start of the next video. So if you want to watch me do this, you can watch the next video.